CloudDB, shaping your new normal.
Welcome everyone to the 2021 APAC Groundbreakers virtual tour. This year our event will be the biggest one ever done with 144 sessions, including normal sessions, workshops and hands-on labs from 100 different speakers over 18 days. Also, it will cover sessions in 4 different languages. Please remember to register to as many sessions as you can. This way you'll be able to have access to our replays until December 30. I would like to say thanks to our Oracle user groups and Java user groups that made this event possible, and also to our sponsors, Oracle Groundbreakers and CloudDB. Now for today's session, Implementing Cloud Native Apps on OCI by Sven Bernhardt. Please feel free to ask questions at any time by using the chat window in your right lower corner of your screen, and Sven will be answering your questions at his convenience or at the end of the session. If you have any issues during the transmission, please feel free to use the same chat window and I will try to help you the best I can. Now, without any further ado, I leave you with this amazing session by Sven Bernhardt. Sven, the room is yours.
Thanks for the introduction. And hello also from my side. Let's getting started with the session. Just a couple of words about me. I'm Sven Bernhardt. I'm located in the Cologne area in Germany. And I'm working for Opitz Consulting, and we are a German Oracle partner since 30 years now. I was dealing a lot with Oracle toolings from SOA Suite and OSD implementations, and now shifting slightly my focus away from that and going over to all the cloud native stuff with respect to containerization, API service mesh, all the cloud native application development style. And this is why I wanted to talk about this very interesting and challenging topic and how the way we implement applications have changed over the last couple of years. And without any further delay, I will jump into the topic. So why do we need to care about cloud native? So the main challenge for all companies nowadays is that they need to ensure the ability to innovate, and the digital innovation benchmark, which was published by Kong, found out that a lot of companies are feared of being absorbed by competitors, or that they might potentially come out of business if they are not able to have the ability to innovate, to be as fast by adopting new trends, technologies as the direct competitors in the market, right? And to be that flexible and to being able reacting on volatile business requirements and on changing requirements from the market side, we need a very flexible IT system landscape that supports this speed of evolvement. So we need a very robust and flexible IT landscape with the ability to change, right? So where change is change on daily basis is the new normal, right? And for that we need to take a look into cloud native apps, so away from the traditional way how we implement applications, because cloud native apps are designed for change by default. So, and key concepts with respect to cloud native apps are loose coupling, resilient and fault tolerancy. Cloud native apps are scalable because they are they are built with dynamic, scalable infrastructures in mind. So either on the cloud side or on the on-premise side. And they are per default manageable and observable, right? Manageable in the sense of that we use infrastructure as code, that we use concepts like GitOps to consistently manage our applications, our code, so that it is comprehensible, who is changing respective resources within my application design, within my infrastructure, and all that kind of stuff. And last but not least, we need to be able to observe the applications, because we have loosely coupled application, or our applications consist of smaller modules that are self-contained in the sense of microservices. We need to care about observability, to being able to trace down all communication between the different services, because we are ending up with a bunch of services, no longer packaged applications that we deploy and manage as one deployment. So, and the cloud native apps, when you build cloud native apps, there are some characteristics which you need to adhere to. So, for example, the 12-factor app methodology. So there are some basic guidelines. It's not completely new. It's just things to think of when you build applications, right? So, for example, that your code should be organized properly in a source code management system and all that kind of stuff. And yeah, that's basically it. And characteristical for cloud native apps are all the new concepts as displayed in the graphic below. So microservices, I talked about it. DevOps. So the basis for all this highly frequently changes is that your application delivery is completely automated, right? So that there are as less as manual steps as possible, right? So with continuous integration, continuous delivery, and container technologies to being able to roll out new application parts or change parts very easy and lightweight, and to have something that is capable to run independent of any runtime, right? To be portable. This is also something which is important. But cloud native, and this is one important point which I wanted to highlight. Cloud native is not just about cloud or building applications for the cloud, because cloud native applications should also be capable to run on-prem or on-prem environments. But from my opinion, if you start building new applications nowadays, even if you wanted to run them on premise, you should build them with cloud native principles and design guidelines in mind, to be flexible and to be able to lift and shift those applications to dynamic cloud environments, and that those applications are directly able to also leverage from the advantages of the underlying cloud platform, and to make use of all the benefits from the cloud. This is very important to keep in mind, right? And when you implement cloud native apps, they are, as I said, portable across different platforms, usually. And also from a developer's productivity perspective, it is important to follow those cloud native principles, because what cloud native also says is, if you look, and we will come to this later on, if you look to the current technology landscape, this is a huge bunch of technologies that are around today, and you need to choose wisely which technologies you can use to help you with certain challenges. So times where we really implement things like security, like logging, like tracing, like metrics are gone. So you should make use of the capabilities of the underlying platform, right? And not implement those technical aspects also for fault tolerance and all that kind of stuff, scalability. You shouldn't build that on your own. You should really focus on business functionality, because this also brings focus on business requirements and also guarantees faster time to market. And this is important with respect to the ability to innovate, right? And I said it in the very first beginning. From the traditional to cloud native systems means that we are moving from single deployment units, single execution processes and shared databases over to multiple deployment units that are each running in exclusive execution processes, and maybe also have individual databases, and not only relational databases, but also graph databases, key value databases, document databases, maybe also time series databases, depending on the use case. Now, so they have to deal with polyglot persistency at that point. So, and this makes you very flexible, but also make your system environment more complex, because you have more remote communication. And for example, concepts like a service mesh can help you to deal with this remote complexity without implementing things like security and fault tolerance and stuff in your applications, but declaring it in a separate infrastructure layer, the mesh layer, right? So how do we get to cloud native, and what does this mean, this cloud native stuff? So first of all, the loosely coupling we can achieve through adopting the API design first approach, right? So when we have self-contained application modules that are communicating remotely with each other, and maybe are also consumed by other applications, we need proper contracts, so APIs that are used to access the functionality of those modules. So on those APIs might be synchronous, and maybe they are also asynchronous, especially when we are talking about bounded contexts. And if we have cross-domain communications, you should use asynchronous APIs. From my perspective, the asynchronous communication way is always the preferable, because you are gaining much more fault tolerance from it, because it decouples the services. Whereas when you have a synchronous REST API, you have a certain level of coupling still. You have a loosely coupling, or still have a certain level of coupling there, because if your API provider is not available or has a problem, you as a consumer have to take care of handling all this error stuff that can occur with this. Important at that point, synchronous API are not just REST APIs defined by OpenAI API specification, but synchronous APIs might also be GraphQL APIs or gRPC APIs, right? And on the asynchronous API side, we have async API specification. But the very important thing is, before we start coding, we should define a proper API, so that consumer and provider can work against this API. So even at the development time, we can directly decouple the client and the server side. So, as I said, automation is key for being able to deliver on a daily basis, or even multiple times on a day. And for this, it is important to have a proper code and deployment pipeline, and everything set up with continuous delivery, continuous deployment. So the code pipeline runs often on a daily basis, because the developers are making changes. They are pushing to a Git repository. This kicks off the code pipeline, where we do different steps, building the binary artifacts and doing some verification in an automated way. And then if we wanted to really deliver this a feature to production, we can then start deploying the build artifacts, so the containerized applications and everything which is around that, to the different environments, and doing acceptance testing, load testing, security testing, and then deploying it finally when everything succeeds to a production environment and create a respective release. So, and on this way, we should have as much as automation as possible to be more effective, to be able to deliver fast, and also to minimize the ability of failure. So, and one very important thing with cloud native is, especially if we implement containerized applications, is that the developers need a changed mindset, because the developer as such has more freedom when we build cloud native applications, because since we have self-contained applications exposing their functionality over an API, we are able to choose the technologies we wanted to choose. We are not bound to any technological borders. We can choose the right technologies or the proper technologies for a certain use case. The shift left means that that we as developers we are also required to take the responsibility and doing things earlier in the life cycle. So things like security testing, without requiring a security expert to join us. So, and what does this mean? Especially if we look to containerization, we need to ensure with container image scanning and stuff that our containers doesn't have any vulnerabilities that might potentially opens the surface for attacks from the outside world for hackers and all that kind of stuff. So security is a very important thing and should also be tackled in a very early step in the code pipeline by the developers. So when they commit the code changes and the binary artifacts are built, and if we go back to the lifecycle, in this automatic verification stage, we should directly check for vulnerabilities, for example. We should directly check the code, static code analysis, and all that kind of stuff. So to being able to fix those issues at a very early stage, and not in this latter stage, for example, fixing vulnerabilities with the container images in the security test, because this is a late point in time, just before the release, and then we need to roll back everything, change it, and then run through each and every step again. And this isn't efficient, and this is why we need to shift left this and other responsibilities to the developer. So the developers have more responsibilities, and to being able to do their work efficiently, the developers need proper tool sets and tools to support them with those new responsibilities. And this is the full power of tools. So this is the CNCF Landscape, and just a part of it, with tools that can be used in different stages of your cloud native journey to help you with certain aspects of cloud native application development, right? So for example, here service meshes, API gateway, service proxies, CI/CD stuff, and all that kind of things. And going further, there's also, when you start your journey, you can take the cloud native trail map from the CNCF, which gives you kind of a guideline on which points you should think of when you start your journey to cloud native. So, for example, first of all, you should think of containerization. So how should I do my containerization? How should I build my containers and all that kind of stuff? How should I, in the next step, how should I support my continuous integration, continuous delivery? In the next step, you should think of orchestration, application definition, and then especially on observability and analysis. And then after this step 4, the other steps are, can be seen as optional depending on the use case. And when you grow your cloud native application landscape, then you can think of all those aspects. But getting started, from my perspective, those 4 basic capabilities, these are the ones which you need to take into account when you start your cloud native journey. So with respect to OCI cloud native services, in the last couple of years, there were great involvements, and they have a cool stack of tools which allows you to consistently implement cloud native applications. So, and I try to categorize those OCI cloud native services. So the basics for all is OCI, so the cloud native infrastructure, all the network, compute, storage, and load balancer stuff. On top of this, we have cloud native services in the area of application development, so providing the development platform for my cloud native application development. So things like container registry, artifact registry, DevOps, cloud service, and resource manager. So basically, the container registry is a Docker registry where I can push my images to, and I have private repositories or even public repositories. So, and this is especially with respect to application delivery to Kubernetes. We need the container registry to get involved. The artifact registry is a registry for non-container images. So for everything other than container images, you can use the artifact registry when it comes to especially the deployment pipeline. So for example, you can upload your Kubernetes manifests to the artifact registry and refer to the artifact registry from within the DevOps service to deploy your applications to the Kubernetes cloud service. Last but not least, we also have the resource manager, and the resource manager is let's say it's like a managed Terraform service that allows you to provision all the OCI cloud native services and also all OCI resources. So infrastructure as code, immutable infrastructure, and all that kind of stuff is supported by the resource manager. So from an application runtime perspective, we have the Kubernetes, the managed Kubernetes, so container engine for Kubernetes here. We have API gateway, which is a completely managed API gateway that you can use. It's a public service, and you can expose all kind of REST APIs through it, and you can also define your REST API based on Open API specifications, and then provide your API deployments, expose your APIs to the outside world, and manage it respectively. Secure your APIs and all that kind of things. Another service is the Oracle Function Service, where you can build function as a service style applications. And function service is based on FN project. So you just have to care about your business logic, write your business logic, and then with the FN CLI, you are able to package the function and deploy it to OCI. So you are not required to think of the underlying infrastructure of containerization, all that kind of stuff, just implementing your business functionality you wanted to depict and deploy to the function service. And then the functions are also only consuming resources when they are triggered by events, by REST calls through the API gateway and all that kind of things. So this is the difference to containers running on Kubernetes. Last but not least, we have the streaming service, which provides a Kafka compatible streaming service that you can use to asynchronously communicate between your cloud native applications for depicting high value streaming applications, also in the area of IoT, for example, because the streaming service is very scalable, robust, and is capable of handling hundreds of thousands of consumers. And to being able to monitor all my cloud native applications, I can use the operations services. So like monitoring, logging, notifications, application performance monitoring, and events. And notifications and events are quite useful because everything what happens inside OCI ends up with an event. So if I do a backup of my database, an event is thrown. If I do commit and from the commit run a build pipeline in DevOps, this also creates an event. And all those events can be integrated with other services. So I can forward events to the streaming service and can from there kick off Kafka consuming applications on Kubernetes. I can directly from the event service trigger functions to do something. I can also integrate events with the notification service, and from the notification service, I can send emails, I can send SMS, I can send messages to Slack, and all that kind of things, right? So I'm able to notify my operations team or my product teams about events with respect to their services. And I can also, from my applications, publish event to the event service, and so trigger notifications there. So here you will be able to download the slides also from my SlideShare account. I will share it afterwards. So just quickly run through it. So here some details about OKE, some details about the API gateway. I already explained this. Functions, streaming, the container registry, artifact registry, and the DevOps service. Here I wanted to stop because I wanted to just explain what the DevOps service is, because I think it's a very cool and valuable service within OCI. So it provides a code repository, and this code repository is a basic Git repository. You can use it to commit your codes, to manage your source code. That you are also able over external connections to mirror your existing GitHub projects, to mirror your existing GitLab projects, and then include your GitLab and GitHub codes repositories with or integrated with the OCI DevOps service, and triggering build pipelines, for example. So build pipelines trigger the build to create the binary artifacts, for example, Docker images that can be pushed to the container registry, or also other non-containerized images that are published to the artifact registry. And from the build pipeline, I can trigger respective deployment pipelines, and those deployment pipelines then can be used to deploy applications. Oh, one arrow is missing here. Sorry for that. Can be used to deploy new applications to OKE, to functions, and to compute. And OKE and functions as such leverage the image or loading the images from the container registry. And from the build pipeline, I publish artifacts, so-called artifacts, to the registry and to the registries, so artifact and container. So this is quite cool. Resource Manager, we were also talking about monitoring, logging, events and notifications, application performance monitoring, which provides a distributed tracing as a service built upon open standards like open tracing, open telemetry, and also allows integration with modern microservice-based apps. I created a demo case for this session, so that uses a lot of those services we've already seen. So we have the DevOps service. So I built a Micronaut cloud native app. My code is managed within DevOps, and as soon as I push my code, and I trigger a build pipeline, an event is generated, then the event is consumed from the notification service and sent to a Slack channel. So I'm informed by Slack about all the events that occur, so that the build was triggered, that the deployment pipeline was triggered, and that the deployment has been rolled out to my OKE instance. So from the DevOps service, I publish my build artifacts to the artifact registry. I publish to the container registry and deploy to OKE, and then expose my OKE service using the API gateway, and then consumers are able to call to the provided API. So, and just wanted to jump into some demo stuff. So this is the resource manager. Oh, forgot to mention, my infrastructure was set up using the resource manager. So for example, here my OKE instance is a defined stack, and I can consistently apply this stack, and when the demo is done, I can also destroy my Kubernetes cluster. And when I wanted to show this demo again, I can again apply this stack, and then my Kubernetes cluster is up and running within minutes. So this is a very cool feature. The same applies to the API gateway and the respective API deployment. So when we go to the APIs and to the gateways, what we can see here, so the use case is that I have a technologies API, which is used to manage technology. So we internally have a technology management tooling. So in the sense of a technology radar, where we manage our technologies within different lifecycle phases, so new, trial, assess. So it's very similar to the technology radar provided by ThoughtWorks. You can see here my API gateway deployment. Where I have my API deployment in place, and here we can directly also monitor our API that is deployed. So the technology API, there were no calls within the last couple of hours. So from that perspective, this is the thing. And then when we look into the DevOps project, we have this technology management stuff. I have a code repository. I have API service, API spec. Because it's separated, I have chosen a API first approach. But first of all, here I have my source code for my API service. Right, so my technology API implementation in Micronaut. I have it here in my real code, and if I go to the technology API service, I can see that I've made a change just before the session starts. I edited the README. What I wanted to do is I wanted to add this change, commit it, edit README MD, and then what I want to do, I wanted to push it. So I push it to my code repository, so to DevOps, blah blah. And what we will see is that from this commit, from this push, a respective build pipeline is triggered. And what we can see here, we have a new message in Slack, 10:36 a.m., that a new build has been triggered, right? And if I go here, I can directly go to the build pipeline and watch the build pipeline. So this is my build pipeline. So build the artifacts, push the Docker images and the Kubernetes manifest, and then trigger OKE deployment. So with a deployment pipeline, I have here my build history, and I can see, okay, there's currently a build in progress that have been triggered by a commit. And once the build is done, I will receive further messages that the different pipeline steps have been run through. As I said, I built the application using an API first approach. For that, I used the API design tool Insomnia. You could also leverage Oracle APIary. Why I choose Insomnia? Because I have an integrated IDE for designing my API and also debugging my API directly. So what we can do here is we can directly call out to the service on OKE. We can see, okay, there's obviously a technology item included. And I can also post new requirements. So for each and every endpoint, I have a respective debugging collection here. And the cool thing is I also have a test suite, right? So I can run tests and double check if the API deployed to OKE adheres to the contract that is defined. So this is all about the API governance. And the cool thing is also when we use a tool like Insomnia, there is also a respective CLI tool calling the Inso CLI that can be used in our CI/CD pipeline to, for example, execute those tests for creating Kubernetes manifest out of the API description. For example, if you have an ingress controller and wanted to expose the API using ingress definitions. So all that kind of things is possible with the Inso CLI. But this is another part of the story, all about the API ops approach. This is not covered within this session. Just to give you an idea, right? So I started with the API definition. From that, I jumped into my code. I have here's my spec. Then I jumped here into the implementation. So this is my service implementation, but I also have this API, and this is just a generator project which takes the API YAML and creates the respective stubs. And my service implementation uses this stubs. So now my deployment is done. I've received additional Slack notification. Deployment has started. Your build run has succeeded, right? So these are events that are published by the DevOps service to the respective event topic, and from the event topic using the notification service promoted to Slack. And now I'm 100% sure that deployment has been succeeded. So it's a very cool thing, and so you gain transparency over your deployment lifecycle and your application lifecycle, right? That's it basically what I wanted you to show. So very cool, very interesting stuff here. Back to the presentation, the conclusion. OCI Cloud Native services embrace open source and open standards, and that's a good thing, right? And over the last couple of years, Oracle is actively contributing things to the open source community. So they are using open source toolings within or for implementing their cloud services. So they are also not reinventing the wheel. So they are using what is provided by the market, which tools are best practice. So they are leveraging CNCF managed tools and standards for building their applications, for ensuring the interoperability with other cloud providers in the notion of multi-cloud applications, which will be the future from my perspective. So, and also they are actively creating new projects in the open source area. So Helidon, Micronaut for service implementation, those two projects. We have GraalVM for an alternative to the JVM, and also for polyglot applications. Then they are contributing actively to Kubernetes, and also providing respective operators for WebLogic for the database to be incorporated with your applications. And multi-cloud apps can be easily built with Oracle Verasano. And Verasano is a quite new open source product from Oracle, and can be used to modernize existing workloads. So if you have WebLogic-based applications, you can lift and shift them to the Verasano platform and co-locate them with the new application style. So with cloud-native containerized applications written in Helidon, in Micronaut, and all that kind of stuff. And the Verasano platform is handling all the network security observability challenges in the over different clouds, and also covering multiple Kubernetes clusters. So also your on-prem Kubernetes cluster can be incorporated, and this is then one big application network, which can be consistently managed using the Verasano platform, also monitored and observed, secured, and managed. And this is a very cool framework, which you maybe should take a look into if you have, for example, WebLogic applications and all traditional application workloads that you wanted to maybe lift and shift in the cloud. And after you lift and shifted it in the cloud, you should also think of re-architecture your existing applications to come more to this cloud native notion of application development. So the key takeaways from my perspective, as I said on the very first beginning, new applications today should be built in a cloud native fashion, right? And basic building blocks for cloud native applications are containers. We have DevOps, CI/CD, APIs, and all the technology and the power of the technologies that are around today. And we as developers should not fear this complexity and this new technologies. We should embrace them. We should use them to be able to be more efficient from a development point of view, right? And OCI has a great offering, as we've seen. It's interoperable. It's built on open standards, open source, and it has built-in management capabilities. And applications built on Oracle Cloud Native are also designed to run in multi-cloud environments. And with that, I'm done with my presentations. Thanks for your attention. Not sure if there are any questions. Obviously, at least I don't see any questions here.
Yes.
If you should have any questions afterwards, reach out to me. Thank you.
Can you hear me, Sven?
Yeah, I can hear you.
Okay, yes. No, I cannot see any question coming at the moment by the chat, and also just giving some time to see if any questions come from through Facebook. In the meantime, thank you so much for an excellent presentation and for taking the time to share your knowledge with the Asia Pacific and global community. And hopefully, in the near future, we'll be able to have more events face to face, and we can have you and others coming to Asia Pac and visit all the conferences around the countries once again.
Looking forward to it. And it was also my pleasure to be here. Thank you.
No, you're welcome. All right, is no questions coming in that case? If you're watching the replays or you wanna do or you wanna do a question to Sven offline, he was just showing on his screen his contact information, where you see you saw his email, his Twitter handle. Please feel free to contact him directly. He's in screen again, and he'll be answering any question in case you want to ask him directly, or if you are watching the replays. Thank you so much, Sven, and please take care and be safe. And to everyone, please have a good evening, good morning, or good afternoon, depending where you are around the world. Thank you so much, Sven.
Thank you. Bye-bye.
Bye-bye.
CloudDB, shaping your new normal.